dimensional representation of the physical quantity. In this class, we are studying about dimensional formula for physical quantity in which we study about some fundamental unit. The fundamental unit is a free-form unit that can be represented in SI unit or in MKS unit. According to classification of unit, another unit is derived unit, that is basically based on, that is basically formed by the application of fundamental particles unit. We have mass, their unit is kg, and that can be represented as dimension as m. Note it, it is very important for everyone, either of any classes, either of any and different field of the life, and also measurement about the system MKS, CGS, FPS, all the systems of unit. Length, that is measured by m, that is meter, represented by L here. Time, that can be measured in second, that is S, but represented by T. These three are the basic fundamental unit temperature, that can be measured by Kelvin, represented by K. Luminous intensity, that can be measured by calendula, CD and represented by also CD. कैंडुला को हम CD से रिप्रेजेंट करते हैं। उसके बाद आता है इलेक्ट्रिक करंट, that can be measured by ampere represented by A. Last, amount of substance that can be represented, measured by mole and represented by mole. These are 7. 1, 2, 3, 4, 5, 6, 7 are the fundamental unit. Always remember these values. Mass can be represented by M, length can be represented by L, time can be represented by T. Now, dimensional formula of physical quantity. Now, I am going to start about some initial physical quantity. Some initial physical quantity, that is, at first area. Follow it, because area of a square is side into side, area of a rectangle is length into base, and so many. There are different, but side can be measured by meter, length can be measured by meter, base can be measured by meter, height can be measured by meter, depth can be measured by meter, and so on. So you have always remember area equal to length into breadth, BR. Length is measured by meter, breadth is also measured by meter. So this is m into m, that is m square. Their dimension will be L square. But first three, mass that is represented by m, length that is represented by L, time that is represented by T, the basic fundamental unit of a physical quantity. So it can be, if one can retain this form, that is the wrong form. So we have take M, L, T here mass is absent, time is absent, so we write m naught L2 T naught now enclosed by the big bracket. This is the real way to determine a dimension. Now, volume of any shape means L into B into H all are a measurement of all L, B, H, length, breadth, height, all are measured by meter, so it may retain, that is MQ, so we can write it LQ. Basically wrong, but finally I dealt in form of T naught, M naught, LQ, T naught, real way. Density, according to the definition of density of a substance is the ratio of their mass and the volume. So, density equal to mass upon volume. Volume is L into B into H, mass is kg, इसका यूनिट होता है kg, और वॉल्यूम का यूनिट क्या हो जाएगा यहाँ के मुताबिक मीटर क्यूब, that is kg meter minus 3 power, that can be written as mass is present, so m L minus 3 T naught, ml minus 3. Frequency, very important physical quantity. Frequency, equal to 1 upon time period, that is 1 by S per second. Second, that is represented in form of T. M is not present, L is not present, T is present as M naught, L naught, T minus 1 in big bracket is the dimension of frequency. You have studied about velocity, speed, motion. The SI unit of these all are ms minus 1, so their dimension will be m naught, L, t minus 1, t minus 1. Acceleration that is v by t, velocity upon time, that can be qualified ms minus 1 by s, that is ms minus 2, its dimension is m naught l t minus 2. Force, as you know, force is the physical quantity. Force can be defined as the action of pulling and pushing of a body that influence a displacement and tends to change their position in the direction of acting force. So, force can be say as ma, mass into acceleration. So, here acceleration A equal to v by t, that can be represented m into v by t, that is m into displacement upon time into time. If we take its unit, that is kg meter s2, that is kg meter s minus 2, their dimension is m l t minus 2. This is the dimension. Impulse, a product of force and time, is called impulse. their dimension is m naught L T minus 1. Impulse is a type of force. Work, energy, Fs. Here F is force, S is distance. Therefore, the dimension of force is ml t minus 2 into t, that is ml t minus 2 plus 1, that is ml t minus distance, m. Power equal to capacity of doing work is called power. So work by time, that is kg meter s minus 2 upon s, that is kg meter s minus 3, that can be represented in dimension kg, that is m meter L square time minus 3 is the dimension of power. ml2 t minus 3. Momentum, that is mass into velocity. The dimension of mass is m, dimension of velocity is Lt minus 1. The dimension of momentum and dimension of impulse both are same. Pressure and stress. Pressure, stress, pressure equal to, definition of pressure is the the ratio of momentum upon force and the area, that can be represented as mass into velocity upon mass into velocity upon force upon area, In this way, I would define it. Pressure and stress is the ratio of force and only area, that is force upon area. Dimension of force and this, that is before the SI unit, S minus 2 upon area is L square, means M square. So that is kg meter 1 minus 2 S minus 2, that is kg per meter per square second, that is M L minus 1 T minus 2, M L minus 1 T minus 2, that is the dimension of pressure and stress. Here is strain. Strain is the effect of force. So if force can change the shape and size of an object due to influence of force, so it can be written as the ratio of an object change in dimension upon the original dimension, change in dimension and original dimension, that is L upon L, length by length, meter by meter, meter by meter, equal to L by L, L by L. So, or it can be also depends on change in dimension, change in volume by original volume. In this way, there are this oblique MQ upon MQ. The dimension of strain is वेरी डिफ़िकल्ट थीम। अगर हम इसके L और M और M को काट दें तो क्या होगा, 1 होगा, या नहीं इसके इसको काट देंगे तो फिर 1 होगा। अकॉर्डिंग टू द रूल्स ऑफ डायमेंशन द नंबर सिस्टम is dimensionless. So there is no mass, no length, no time is present here. So we write it is dimensionless. Here is the number 1 or 1. So in the form of dimension M, L, T, all belonging by the naught. M naught, L naught, T naught means number system has no dimension. इसको डायमेंशन नहीं होता है। नेक्स्ट, सरफेस टेंशन। Surface tension is the ratio of acting force and the length of the object. तो हम चलते हैं नेक्स्ट में, सरफेस टेंशन, एक्टिंग फोर्स and the ratio of length. According to SI unit, SI unit of force is kg meter s minus 2 upon SI unit of length is meter. So these both are eliminated. Now we have only kg s2 minus, and their dimension here M is not present, meter is not present. So we write M L naught T to the power minus 2. M L naught T to the power minus 2. चलते हैं हम लोग सरफेस एनर्जी पर। अब सरफेस एनर्जी को आप देख लीजिए। एनर्जी, द टर्म एनर्जी, चाहे वह एनर्जी किसी भी प्रकार की हो, उसका यूनिट वर्क के यूनिट के ही जैसा होगा, उसकी डायमेंशन वर्क के डायमेंशन के ही जैसा होगा, ठीक है। लेकिन सरफेस एनर्जी को हम लोग डिफाइन कैसे कर देते हैं, उस आधार पर देखेंगे कि सरफेस एनर्जी की डिफिनेशन क्या होती है और उसका फॉर्मूलेशन क्या होता है। तो सरफेस एनर्जी इज energy acting on a certain area. Energy and the ratio of area. एनर्जी की जो SI यूनिट होती है वह वर्क के SI यूनिट के बराबर होता है। तो हम लिखेंगे वर्क डन बाय एरिया। आपने सबसे पहले हम एरिया की डायमेंशन को देखे थे। एरिया की डायमेंशन क्या होती है, वर्क की डायमेंशन क्या होती है। तो वर्क का हम पहले और एरिया की पहले हम यूनिट को देख लेंगे। तो इसकी जो यूनिट होती है केजी मीटर s माइनस 2 m2 s माइनस 2, ये है वर्क की SI यूनिट। और एरिया की SI यूनिट होती है मीटर स्क्वायर. सो these two are eliminated. Two are eliminated. Now we have only kgs minus 2 that can be represented in dimension m naught, m L naught t minus 2, t minus 2. Today the class is ended. You have already finished it and remember it for the coming examination.